Where do you suppose life would be if it existed on another planet in the universe? This issue has been debated by scientists for millennia. However, modern scientists are equipped with the more sophisticated instruments, the most sophisticated of which being the new James Webb Space Telescope. This powerful observatory in space has already found a target and is producing encouraging findings in the hunt for new life. Artificial light is one among the clues of intelligent extraterrestrial life that the JWST is looking for when it examines Proxima b. What on Proxima b has this telescope discovered specifically? Should you be preparing for an alien visit? Why is it searching specifically for artificial lights on the planet? Hello there, and welcome back to the Discover Space channel, where we bring you the cosmic discoveries you'd really want to know. Subscribe if you haven't already, and let's get on to the video. Years of telescope construction have resulted in none coming close to the James Webb Space Telescope. In actuality, it has 100 times the power of the Hubble Space Telescope, which has been bringing back breathtaking photos of outer space for 30 years. The JWST is so sensitive to infrared light that it can pick up even an insect's faint heat at lunar distance. NASA said that at a distance of around 25 miles, it could also see objects as small as a coin. Of course, NASA is not sending a $10 billion telescope into orbit to look for insects or coins. The goal of the study is to provide a clearer picture of the galaxy's formation and perhaps provide some answers to some enduring mysteries about the early universe. The Hubble telescope is renowned for taking mesmerizing pictures of space, but it has a drawback. It cannot let astronomers observe the very earliest galaxies that emerged from the Big Bang. The JWST will fix this. You could say that NASA has installed a gigantic time machine in orbit, many hundreds of millions of years more than Hubble. Astronomers will be able to sample light that has been traversing the cosmos for as long as 13.5 billion years. The sunshield that keeps the JWST cool is one of the most recognizable features. In order for the telescope to operate as intended, this cooling is required. The shield, which is as huge as a typical tennis court, had to be folded in order to fit within the launch vehicle. Temperatures on the side facing the sun will be around 260 degrees Fahrenheit, while the opposite side will be nearly 600 degrees colder at roughly 375 degrees below zero. The primary mirror, which will be divided into 18 segments and has a gold covering so thin that a single strand of hair is 1,000 times thicker than it, is the focal point of JWST. For its launch, this mirror had to be folded. The JWST is actually beyond repair, which, depending on your perspective, can be both an interesting truth or a terrifying one. It can't even be refueled right now because it's too far away to send a crew in for a repair. Contrary to the Hubble, which has been visited numerous times for maintenance and part replacements, the newer telescope is located 1 million miles distant, whereas the Hubble is only 340 miles away. Therefore, the $10 billion risk known as the JWST mission solves the telescope's first significant issue. Due to its advanced components, the JWST will not only focus on the past, instead, it will aid in the research of exoplanets or worlds outside our solar system. Exoplanets are extremely challenging to find. let alone study, before the JWST mission. One exoplanet has drawn the attention of scientists in particular, but detailed research into it had to wait until the JWST mission. Which exoplanet do scientists want to investigate the most? Why do they want to investigate it? And why are exoplanets so challenging to find and study? The distance between them and us is the first factor. Outside of our solar system, the nearest stars are so far away that, bearing a major advance in space travel, we cannot send astronauts there. The second issue is that these exoplanets revolve around stars that are so brilliant that it is difficult to spot the planets in their orbits. It's comparable to attempting to examine something far away that is right in front of a bright light. Therefore, scientists had to develop other techniques, such as the transit method, which watches how a starlight temporarily dims as a planet passes in front of it throughout its orbit. This technique is used by the Kepler Space Observatory to find exoplanets, and scientists can use the data to work out the planet's sizes and orbital periods. In reality, this technique has been used to find the vast majority of exoplanets. However, the JWST's launch will make exoplanet hunting easier, and one of the exoplanets that researchers are excited to examine is Proxima b. What makes Proxima b unique? The similarity between Proxima b and Earth is its most intriguing feature. This exoplanet is only 4.2 light-years away from Earth and only slightly larger than our planet. A group of researchers has discovered several facts that strongly imply that there are evidence of life on Proxima b, utilizing the HL spectrograph, the rocky exoplanet, and stable spectroscopic observations, or ESPRESSO. The ESPRESSO spectrograph from Switzerland is currently fixed to Chile's European Southern Observatory's extremely big telescope. In order to analyze an object in greater depth, spectrographs observe objects and separate the light emanating from those objects into the wavelengths that make it up. The planet Proxima was only recently found, as researchers only learned of it in 2016. With an accuracy of more than 1/10 of the mass of the Earth, scientists were able to calculate the planet's mass due to ESPRESSO. The position of Proxima b in relation to Proxima Centauri, the star closest to Earth, is more intriguing. It is in the habitable zone, or the path around its star, where conditions are just right. Considering the temperature, this indicates that liquid water may be present. One of the prerequisites of life as we know it is water. Unlike the Earth, which takes a lot longer to orbit around the Sun, Proxima b completes its orbit around its star in just 11.2 days. This is due to the fact that it is closer to its star than the Sun is to the Earth. However, the exoplanet is still able to stay in the habitable zone since the star Proxima Centauri is significantly less stronger than our Sun. Actually, Proxima b gets almost the same amount of energy from its star as the Earth does from the Sun. Proxima b is tidally locked to Proxima Centauri, which causes one side of the planet to be permanently facing the star and results in permanently dark and permanently brilliant side. The Earth and Moon are in the same cosmic interaction. Using the JWST, researchers will be able to confirm whether or not Proxima b has an atmosphere. To shield the exoplanet from potential radiation from Proxima Centauri, an atmosphere may be necessary. Additionally, Proxima b will be able to retain any water it may process thanks to the atmosphere. Scientists hope to explore another indicator of life on Proxima b. The JWST will be very helpful in this effort. This is one of the clearest indications of extraterrestrial life on an exoplanet. The inspiration originated from the fact that Proxima b is tidally locked to its star because one side of the exoplanet is perpetually dark, as we mentioned before. A.V. Loeb, a Harvard astronomer, has proposed that technologically evolved aliens may be employing artificial lights to enlighten their surroundings in a similar way as to how we would turn on a light when it becomes dark. One way to obtain these artificial lights is by using large mirrors or extremely bright LED lights. All we have to do is to prove that there are aliens on the exoplanet and photograph these brilliant lights. And here is where the JWST comes into play. But is it truly feasible that extraterrestrial life may decide to reside or operate in the shadowy regions of Proxima b? Chinese researchers have succeeded in landing on the moon's permanently dark side. Who knows what the Proxima b aliens are up to in the gloom of their world? According to Loeb, we may identify this man-made light, if it exists in the exoplanet, by utilizing the near-infrared instrument on the JWST telescope and looking for the telltale indications of LED light waves in the light from the exoplanet and its host star. They understand that the JWST is capable of detecting LED-type artificial lights, which account for 5% of stellar power. The near-infrared spectrograph, often known as the NIRSpec, aboard the JWST must operate at peak efficiency in order to support this notion of artificial light. Loeb and colleagues utilized the JWST exposure time calculator to determine that it could be able to identify artificial light. With the help of this technology, astronomers may forecast what will be detectable throughout any given time period, depending on settings that were established before the observatory launched it. They were able to calculate the probability of detecting various flux values, as well as those whose wavelength matches artificial light levels that would be expected from a civilization on Proxima b that existed in eternal darkness.